Okay, let's dive into this idea of immutability in programming, specifically JavaScript. It sounds pretty fundamental.
It really is. Basically, immutability means that once you create something, a value or an object, you just can't change it later. It's, well, fixed.
Fixed, like set in stone. Once
Yeah,
it's made, that's it.
exactly. And that's the opposite of mutable things, which can be changed after they're created. In JavaScript, the simple type strings, numbers, booleans, they're already like this. They're immutable.
Right. You don't really change the number 5 to 6. You just start using the number 6 instead. Same with strings.
Precisely. You get a whole new string if you try to modify one. But objects and arrays, they're the tricky ones in JavaScript. They are mutable by default.
Yeah, you can add an item to an array
Yeah.
or change a property on an object directly. No
Yeah,
problem.
exactly. So the whole point of focusing on immutability in JS is about using patterns to treat these objects and arrays as if they were immutable. You want to change something, okay, but you create a new version with the change, leaving the original untouched.
Okay, but why? Why go through that extra step? What's the payoff for making things immutable when JavaScript lets you change them easily?
Ah, that's the core question, isn't it? And the biggest benefit, really, is predictability. When your data is immutable, you can pass it around your code, give it to different functions, and you have this certainty.
Certainty.
Yeah, certainty that it won't be accidentally changed by some other part of the program. It cuts down massively on those really hard to find bugs caused by unexpected side effects.
Okay, fewer side effects.
Hmm.
That alone sounds pretty good. Less debugging pain.
Definitely. And tied right into that is making it easier to track changes. Think
Hmm.
about it. If you change a mutable object directly, sometimes it's hard to tell what actually changed or when.
Right, you might have to compare everything inside it.
Exactly. But with immutable data, any change results in a completely new object or array. So checking if something changed is as simple as asking, is this the same object in memory as before? Is the reference the same?
Oh, I see. So you just compare the references, not the entire contents.
Oh, yep. If the reference is different, you know it's been updated. That's super efficient.
And that sounds crucial for things like, say, React, right? For knowing when to re-render components, or in state management like Redux.
Absolutely. That simple reference check is a key performance optimization they rely on. Plus, having this history of distinct states makes debugging easier too. You can potentially trace how your data evolved over time.
Okay, sold on the why. It's about predictability, easier change tracking, better debugging. So how do you actually do this in practice with JavaScript's objects and arrays? How do you enforce this don't touch the original rule?
Well, the main techniques all revolve around creating new versions. Probably the most common way these days is the spread syntax, 3 dots.
Ah, yeah. Use that all the time.
Right. So for an array, if you want to add an item without changing the original, you'd create a new one, like dot original array, new item.
Got it. Copies everything over, adds the new thing.
And for an object, if you want to update a property, it's similar. ali.originalObject, property to update, new value. It creates a new object with the changes.
Okay, but those are shallow copies, right? If you have nested objects, the nested ones are still the same reference.
That's a key point, yes. Spread syntax and even object.assign, which you might see used like object.assign, original object, changes, they only create shallow copies. Often that's enough, but sometimes you need deeper immutability.
So what then?
Well, another big part is using the right array methods. Things like map, filter, slice, concat. These are great because they always return a brand new array.
Uh-huh. Unlike methods like push or splice or sort, which actually modify the original array in place.
Exactly. So you choose the methods that give you a new result. For truly deep immutability with complex nested structures, you often reach for dedicated libraries. Though object.freeze exists too.
Object.freeze.
Yeah, it prevents changing properties directly on that object, but again, it's shallow. If a property holds another object, that inner object can still be mutated, so it has limitations.
Okay, so it's a range of tools. Built-in syntax like spread, specific array methods, maybe object.assign, and libraries for the heavy lifting on deep structures. It's about the mindset shift, really.
It absolutely is. Thinking create new instead of modify existing.
Right. So pulling this all together, embracing immutability, even if it takes some specific techniques in JavaScript, seems to lead towards code that's more reliable and just easier to follow, especially when things get complex.
It's definitely a powerful way to manage complexity, yeah.
But it's also fair to say, as you pointed out, that it's not always free, right? Constantly creating new objects can have a performance cost, especially with lots of frequent small updates. And handling deep updates correctly can add its own complexity.
That's the trade-off you need to consider,
Right.
definitely.
Absolutely. So maybe the final thought for you, the listener, is this. Considering these benefits, the predictability, the easier change tracking, and the potential costs or learning curve, where in your own projects do you see the advantages of immutability really shining through? Where does that trade-off make the most sense for you?